All right, guys, we're going to jump into naming now. It's pretty exciting stuff here. All right, so when we name compounds, there's like specific styles for each type of compound. So specific to ionic and covalent and organic. And we're going to get to organic in a moment because organic compounds, their own little thing. They do their own spiel, and you'll see what's up. So we start talking about cations. All right, so this is ionic. Let's see what's going on here. Cations, remember, they're positive. All right, so except, whoops, there's an E there, except NH4 plus, which is ammonium. They're derived from their metal names. And so here what we get is like Li plus, this is the lithium ion, all right? Ca plus 2, this is the calcium ion, and so on and so forth. So if it's Al plus 3, it'd be the aluminum ion. So there we go. Now, binary compounds here are made of two elements. Binary ionic compounds made of two ions. Okay, so those are made of two ions. So it's pretty straightforward. Now, the anion, this is a little bit of a different story. These are negatively charged, all right? And what we're going to do is you use first part and ending change to "ide." Ending now "ide." And you'll see what I'm talking about here, all right? So this is all negative ions. So as you look at this, I got my list here, so I'm going to use a little bit more space over here. Cl minus, all right? Cl minus, that's from chlorine, so the ene becomes chloride. And you don't have to like say ion. When you say chloride, definitely an ion. If I said N minus 3, this is nitrogen, so it becomes nitride. Okay. O minus 2, oxygen is oxide. All right. So we're changing those endings to "ide." That's the idea here. All right. We could go on and on. Any negative ion. All right. Now, transition metals, this is kind of fun because transition metals can have multiple charges. We have to signify that. So with transition metals, we signify charge with Roman, all right, numeral. All right, so here I have, we could use Cu plus 1 or Cu plus 2 because copper can be both, right? Not at the same time, but sometimes it makes plus 1 ions, sometimes it makes plus 2 ions. And if it's this, it would be copper 1. And if this one would be copper 2. And that's it. So iron, Fe plus 2 and Fe plus 3. All right, so this one right here, this would be iron 2 because that's its charge. And this is iron 1, 2, 3. There you go. Now, polyatomic ions, these are groups of atoms. All right, these are groups that have an overall charge. All right, groups with charge. There is a list on Canvas that you're going to have to, like, you'll get it on the tests and stuff like that, but you're going to have to become familiar with it. All right. And so we'll go over that more in class. Now, naming becomes fairly straightforward. All right. It's just cation, because we write the cation first, plus anion. So here what we do is if we have Na and Cl, well, I know those ions are Na plus and Cl minus. All right, our formula is going to be NaCl. So here, our cation name is sodium, and our anion name It's chloride, sodium chloride. It's that simple. So as I move forward here, what we have to do is now we'll do like ZnCl2. Now zinc only has one charge, so you don't have to worry about Roman numerals. This is zinc chloride. And then here, this one's kind of fun. This is going to be kind of a pain in the butt. Cr plus 3, SO4 minus 2. All right. So our formula here is going to be Cr2 SO4 3. And our name is going to be chromium 1, 2, 3, because that's the charge of the ion. Roman numeral, charge of the ion. Roman numeral, charge of the ion. That's what you need to remember. And SO4 is sulfate. There we go. Chromium 3 sulfate. Boom. All right, now we could go through and do all these. So we're going to walk through some of these in class, but we'll do these in class and make sure that we understand everything that's going on.